Dear colleagues, I am pleased to present the result of your work to you. The work was performed at Ivan Franko National University of Lviv. My name is Katerynchuk. I am Associate Professor of Optoelectronics and Information Technology Department. The multilayer neural network used for the recognition of printed digit. We use the fractal structure technique to investigate the tracking of a three-layer neural network. The dataset contained 5 plus 4 variants of digit distortion with an error of equal 15% for the 3 and 5 digit array and 40% for the 4 and 7 digit array. It was established that the appearance of the fractal structure is caused by the retracing of the neuron. We deal with the two-dimensional arrays. We use 3 and 5 and 4 and 7 arrays. The sample this consists of 5 options for presenting the number without distortion and with. If array consists 1 or 0 distortions, we call it homogeneous, otherwise not homogeneous or heterogeneous. The dynamic of the fractal structure was investigated depending on the training parameters of the neural network, in particular on the number of the iteration and the dimension of the input array and its homogeneity, the training step and the parameters for optimization the training process. The number of the neuron in the input at hidden layers correspond to the size of the input array. The program was written in Python and performed the recognition of printed digit. We used the optimization method of training Adam. The objective function is the training error function. The optimization parameters for this optimization method were selected beta 1 equals 0.9 and beta 2 equals 0.999. The appearance of local minimum is described by the process of the doublet of their number by the training error function. The reflection of the fractality will be carried out with the whole out of a logistic function that describes the doubling process. That is a complex function of the form presented on the slide. Taking into account the peculiarities of this mapping, namely that the variable that is a complex quantity in with the real part of the training step is alpha, and the imaginary part is the value of the weight correction function W. The image of the fractal structure was performed in the coordinates, the value of the correction of the training weight W and the training step alpha. The different color represents the speed of moving away from the solution of points that are not included in the solution of the system. Figures shows the view of the fractal structure from the number of the iteration. In the retraining mode of the neural network, a complex boundary is demonstrated with graduality reveals smaller and smaller recursive details when zoomed in. A set boundary is made up of smaller version of the basic form. So the fractal property of the self-similarity refers to the entity set, not just a part of it. With an increase in the number of iterations, there is change in the fractal picture. Namely, the appearance of smaller recursive details can be traced. This slide shows the view of the fractal structure when the changes the step of training alpha. Starting from alpha equals 0.3, the recurrence system describes the magnitude of the training error from the training step and demonstrates the absence of the solution of the system. Under the condition alpha equal 0.4, the system has a single solution and it characterized by almost no retraining process. That is the mode of the neural network training demonstrate a satisfactory training process. A future change in the training step leads to appearance of 4, and so on unstable solution, followed by a transition to the mode described by the doubling process and the transition to a chaotic training mode. Under this condition, the mode of training described by a fractal structure alpha equal 0.4 to 0.7. According to the obtained fractal structure in slide, the chaotic training mode of the neural network is described by the appearance of additional smaller details on different levels. Comparing the obtained fractal structure under the condition of heterogeneity with homogeneous input array, it can be argued that an increase in the heterogeneity of the input array leads to decrease the number of the small details on the fractal structure. When the parameter beta 2 is changed in the range of 0.1 to 0.99, figures 8 and C, no changes in the fractal structure can be observed. At beta 2 equals 0.999, figure D, a change in the smallest details of the fractal structure being to be traced, namely the spatial areas of their existence are begin to increase. A future increase of the parameter beta 2 figure A leads to a more pronounced picture of the such change. So the fractal structure of training of a 3-layer neural network obtained. The training mode of the neural network and the chaotic mode are equally involved in the formation of the fractal structure in the process of the training of the neuron. Heterogeneity of the input array has a negative impact on the formation of the fractal structure of the training process. Dear colleagues, thank you for your attention.